Hi everyone, today I'm going to present you my science project, which mainly talks about the pH scale. So let's see. What's the pH scale? The pH scale measures how acidic or basic a solution is. So like you may ask, what is acidic or what is basic? So I'm going to show you now, starting with acids. So acids and its characteristics. Acids are mainly compounds that have high concentrations of hydrogen ions, and their pH is less than 7. And in the pH scale, 7 is a special number because 7 is like in the middle level. For example, like pure water, it has the pH of 7, and pure water is not acid and not base. So it's like in the middle, it's neutral. And characteristics of acids, as I said, pH less than 7, neutralizes bases, we'll talk about that later, and forms hydrogen ions in solutions, and it reacts with most metals to form hydrogen gas, and it also conducts electricity. And we go to the base. Bases are like the exact opposites of acids, and they have pH greater than 7, and they also have high concentrations of not hydrogen ions, no, hydroxide ions, yeah, hydroxide. And they usually form hydroxide ions in solutions, and they neutralize acids, and we'll talk about that. What do they mean by neutralize acids or bases? So we go to the buffers. Buffers are weak acids or bases that react with strong acids or bases to prevent sharp, sudden changes. What does that mean? So, inside of bodies, for example, or inside a cell, anything living, there are chemical reactions, and they usually happen, suddenly, especially if it is connected to strong acids or bases. If you want to turn a strong acid to a base suddenly, it won't work. So we use buffers. If we add buffers to strong acids or bases, both, they will slow down the chemical reaction and make everything calm, not sudden. So it is beneficial for homeostasis to maintain balance inside the body and not rush in everything. So that's basically the meaning of neutralize. Okay, if you want to neutralize a base, you have to use a weak acid. If you want to neutralize an acid, you have to use a weak base. Okay, so time for an experiment. I'm going to show you an example or an experiment, both for acids and bases. So let's go here. Here is the pH scale, and as you can see, 7 is bolded because it's neutral. Important, and we take this and put it on pure water. Its pH is 7 exactly, and remember, it has to be pure, not salty water, not water with sugar or anything. No, it has to be pure. And here, let's take, for example, orange juice. It shows here that its pH is 3.5, which is acidic, because it's less than 7. And if you added, more orange juice, the pH won't change at all because, it's the same molecules and it'll have the same concentration. But if you added water, pure water, remember, its pH changed. And notice that it gets closer to the 7, or the pH rises. Okay, because, they mix together and it's pure water with an acid. So basically, kind of buffers it. So let's try another acid. For example, soda pop. Here, its pH is 2.50. It's more acidic than orange juice. And if you still added more soda pop, it'll still be the same. But if you added water, the same thing goes here. It gets more. It gets closer to the 7. But there is an important question. Does the same thing happen to bases? Let's see. Let's choose soap because, it's the most common base. and put the scale here. Its pH scale is 10, and still if you even added more soap, it'll still be the same pH. And if you added water here, its pH gets lower, not higher as the acids, because it also gets closer to the 7. So, let's try another base. Here, the cleaner. 13. Oh, it has really high pH. And add water, it gets lower too. So, all in all, if you added pure water to an acid or a base, they both, get closer. The acid's pH gets closer to the 7, or increases, and the the pH of the bases gets less and closer to the 7. So, that's all. And I hope you enjoyed my presentation and experiment. And thank you. That's all.